here we found the volt is VOH minus VS is 3.3 minus 0.5 volt minus 1.7 volt equal to 1.1 volt. Then 2R equal V equal to IR, so we use 2R equal to 1.1 V over 9 MA equal to 122.22 ohms. After we get the result of the resistor is 61.1 ohms. But from here we use the 82 ohms resistor. This is my coding. First, I define port 5 to 7 and port 2, port 3, and port 13. And from here, I enable clock for port A and C and set the port C, C5, C6, and C7 in the port C, and A12 I set port 12, port 13, and 2 in port A. Okay, here is the white set LED. From here I set it when the LED numbers is equal to 0, then I set all the port as an input. And when the LED number is equal to 1, I set port A12 as an input and set high in A2 and set low in A13. And here is when the LED number is equal to 2, I set A12 as an input and set high in the port A13 and set low in the A2. Then if LED equal to 3, then set port A13 as an input and set high at the A12 and set low in the A2. And LED equal to 4, then set port A13 as an input and set high in the A2 and set low in the A12. And LED equal to 5, then set port A as an input and set high in the A12 and set low in the A13. Last is the if LED equal to 6, then set port A2 as an input and set high in the A13 and set low in the A12. Here is the calculation to get the result, to get the volume. Here is if we look volume equal to 0, then it return 0. Volume equal to 1, return 1. Volume equal to 2, return 2, 3, 4, and 5, and 6. After this volume, we will send it to the here. So here is my main functions. Okay. First, we call to initialize system, and for the 4 unlimited loops. So I equal to then call the read input function and set the LED number from the value that from the read input function. Okay. Here I show you. First, we open the LED 1, so it's 100, and for the LED 2 is 010, and LED 3 is 110, LED 4 is 001, LED 5 is 101, LED 6 is 011. Okay, that's all. It's me again. Now I want to show you the Lab E3 part 2 first part, and it's the analog to digital converter. And from here, this is the code I write, and here first I define PT3 mask as a port 0, and I write a simple counting loop to delay some time, and here is the calibrate the ADC system to reduce the error. From here, you will check the calibration whether successful or not. And this function is initialize the ADC, and this function is doing the ADC conversion. And here you will trigger the conversion in channel 14 and waiting for the conversion to complete. And you will read the data into result variable, and this is my main function. First, I create some variable that ADC for 1, for 2, and that's. And you will go to the close initialize, and here I enable the ADC and enable the port C and set the port 0 into the port C and set the port C0 as an input. And here it will print starting up and call the function to initialize the ADC. From here it will 1, then ADC will carry out the conversion and return the result to the ADC, and it will print out the value, and it will calculate for the changing the data value into the voltage level. Here is the calculation, and it will show it the result. And here is the circuit I built. And first, I open the putty. Okay. From here, you can see the maximum voltage is 3.30. When you turn it becomes smaller. The voltage will drop, and it will drop to the 0 volt. That is the minimum voltage. That's all.
This is lab 3, part 2, second part. Okay, in this part 2, we will need to measure the light level available from the light sensor on the FDRM board. Okay, and this is basically the code. Okay, for the first part, to initialize, we will need to initialize the analog to digital converter, and in this part we will need to wait for the calibration to complete. If the calibration is successful, it will print out calibration successful, and next it will need to do the ADC conversion by setting the DIFF mode to 0 and using channel 19. And next, waiting for the conversion to complete, and the result will store into data, and this is the delay function. And next, the result store will be used in the main source. Okay, by using it to do the ADC conversion using the level 1023 minus the data before, and it will print out the light level. Okay, next we'll link to the putty. I'll cover it up for the light sensor, and it can be seen that the light level will turn very low, and when I place a light source, it will detect that, and the light level will become very high. Okay, that's basically about it. Thank you.
Okay.
This is lab 3, part 3. This is basically the integration of part 2, second part with part 1. And the code will first start with the calibration of ADC. This is basically the function that calibrate the ADC, and it will check whether the calibration is successful or not. And this is to check, and this is to initialize the ADC, and this is to do ADC conversion as similar to part 2, second part. And this is from the first part to initialize the Charlie plexing. This is to set the LED number when LED number equals to 0, which means all the LED are off, and LED number equals to 1, the output 1 will be set to high, and the output 3 will be set to low, and the output 2 will be set to high impedance, and the similar loop goes to LED number 2, 3, 4, 5, and 6. This is the main function. It will start and initialize the ADC, And next, initialize the Charlie plexing, the delay function, and next you do the ADC conversion. And for this, the level, the 1023 will minus the data for the ADC, and it will print out the light level. Okay. When the light level is 0 or less than 57, all the LED will be off. And when it is 57 to 21 or, it will set the LED D1 and followed by the respective LED to number 6. Okay. This will next I'll demonstrate the circuit. This is when the light level is low and the circuit. When there's a light source shine over, you light up D6